And 3 seconds later, how did you do? What happened to the k? It's a constant. So the derivative of a constant is always 0. So the derivative of this function, 3x squared, will become 6x, minus 5x just becomes minus 5. The equation of the tangent to the graph at x equals p is y equals 2x minus 9. How do we find p? So this is a type of question that's sort of atypical in the fact that normally we've done so far, find the derivative, then you've got a point, find the equation of the tangent line at that point. And you use all the steps. If we go back to a question that we did, this one's overly complicated, a nice simple one. Find the equation of a tangent. So what did we do? We found the derivative. We used the derivative to find the slope. We used the point to find, we used the x-coordinate to find an actual point on our graph. After we had that point on the graph, we could use the point slope, or y equals mx plus b, to find the equation. So what we have in our question right now is, I'm going to highlight in bright blue, this is what they didn't tell us, right? They didn't tell us what the x point was. Instead, in green, they told us this. What do we have to do in situations like this? We have to work backwards. We have to think, if I knew this already, how does that help me work backwards to find out what I need to know? Yeah, now I can't find it. There it is. So, if we're working backwards, what's going to help us? Right? They told us the equation of the tangent line, 7x minus 9. How does that help us? What's in this equation? We got a slope and a y-intercept. Of those two things, slope and y-intercept, what's going to help us work backwards? The slope. So we know that our slope is 7. And we know that our derivative finds all the slopes, so we can plug in 7 equals 6x minus 5 and find out that x had to be 2, so that means p has to be 2. Now that you know that p is 2, we need to find the value of k. Well, here we have an equation. If I wanted to solve for k, I would need an x value and a y value. Do we know the point that's on that graph? Okay? No, not yet. But if we had, right, if we think about our steps naturally following finding the equation of a tangent, you end up with the equation of a tangent in the end. One of the things that you did partially the way through was get a point. If I draw a picture of what's happening, we have a parabola. We know that at x equals 2 comma something, we have an equation of a tangent line whose slope is 7x, or whose slope is 7 and whose equation is 7x minus 9. This green point at 2 comma something is on the parabola, and it's also on the line. If it's also on the line, then we would plug in 2 into y equals 7x minus 9, and we could find out that the y coordinate is 5. So I can label this point as 2 comma 5, and then now that I know that point is also on my parabola, I could plug in 2 for x and 5 for y into my parabola, and then I could solve for k. I think this question shows a very typical thing that you'll find on an IB exam. Okay? Not only do you need to know how to do something in its normal steps, right? Find the equation of a tangent at x equals 3 to this curve. Okay? So you follow those steps, but they're really seen. Do you understand what's happening along the way so that if we give you information in the middle but missing some information at the beginning, can you do that? Can you work backwards, find information that you didn't know from before? Notice the connection between where the information goes so that you could solve a question like this. And there is a graphing calculator picture of exactly what is happening. So these first questions dealt with tangent lines. Take out your highlighter if you want. The next thing we're going to look at is normal lines. And all a normal line is perpendicular to a tangent line. So going back to grade 10 math and saying, if I know the slope of one line, how do I find the slope of a line perpendicular to it? That's where you take whatever slope you had, make it negative, and flip it, right? In English, we would say the negative reciprocal. In French, you would probably use, right, because reciprocal and inverse are switched in language. But if your slope of your tangent, so I'm going to go MT, was 2/3, then the slope of your normal would be negative 3/2. That's what the negative reciprocal means. If you multiply those two slopes together, you will always get negative 1. So here's your typical find the equation of a normal line question. And it is identical to finding the equation of a tangent question, except for one little switch, where we find the slope of the normal line instead of the slope of the tangent line. So how did we find the equation of a tangent? Well, first, we would find the derivative. And then we would say the derivative, what does that do? What does that mean? The derivative is an equation of all the slopes of all the tangent lines. So if that's the equation of all the slopes of all the tangent lines, and I want to find the one when x is 2, I can just plug in 2 into the equation and simplify. Now, in simplifying negative 24 plus 16, it's negative 8. Normally, I would just write negative 8. But this time, I wrote it as negative 8 over 1 to make it a fraction, because when I flip that fraction, I can easily see what my slope of my normal is going to be. This part right here is the only thing that's new in this question compared to finding the equation of a tangent. The rest is going to be identical. So now that we have a slope, we need to find the equation of the line. In order to find an equation of a line, you need a point and a slope. Now we don't need to find the tangent line yet. So there's our slope. Our point is 2, -5. You could use the point slope form. Plug in your point, plug in your slope. Rearrange it if you'd like. So from the last blue line here, moving forward, I can multiply both sides by 8 to get rid of the fraction. That lets me rearrange it quite nicely. And then I could divide everything by 8 to get my equation of my normal line. Here's a picture of what's happening. We had our curve. We have our tangent line in black. And then our normal is at a 90° to that tangent line. And that's the equation that we found. Change your function to rational exponents, and then you can find your derivative. You can change your rational exponents back to radicals, and this might be easier when you go to evaluate and plug in 1. So we get our slope of our tangent line to be -3. Again, it's nice to write out our slope of our tangent line is -3. That means the slope of my normal is going to be positive 1/3. And then once you have a slope and a point, you can plug it into the point slope form, or you can plug it into y equals mx plus b. How many people So you have a choice of either getting your equation through the point slope form in black or through y equals mx plus b in blue. You get to choose whichever one you prefer. Mathematically, they both took 4 lines. So we find our derivative. And then plug in our value to find our slope. Again, function notation works really nice here for showing your work. Your slope of your tangent is going to be -2. And now you know a slope and a point. And you can find your equation of your tangent line. So what we could do on our graphing calculator, because part B says use your graphing calculator to find the coordinates of the point where this tangent meets the curve again. So what we want to have on our calculator is this picture. I'm going to draw my original graph. So go to my calculator, graph y equals x cubed minus 5x minus 2. And in my second equation, I'm going to graph my tangent line, which is -2x. Might have to change my window here. I'm going to go zoom back to 6 for a standard window. There's my x cubed graph. And there's my tangent line. So my tangent line is hitting nicely at -1, 2. But it also intersects the curve at another point. So what can we do on our calculator? A lot of stuff with graphing that you can solve for is all under the calculate button above trace. So if you go second and trace, this menu comes up. It lets you find specific values on your graph, x-intercepts, minimums, maximums. In this case, we want to go down to number 5 and find where these graphs intersect. If you push enter 3 times, because it says which is the first curve you want, what's the second curve you want, it will always find the intersection that's closest. In particular, we want to find the one on the right. So using our arrow keys, if I move my cursor closer to that one, now when I push enter 3 times, enter on the first curve, it jumps to the second curve, enter again, guess, just push enter again, it finds that they intersect again at 2, -4. That's graphically for solving where they intersect. Okay? If you wanted to find it out algebraically, what would you have to do? You would have to set this equation equal to that equation and solve it algebraically. That'd be solving an x cubed equation. Not as easy to factor, but you could use your factor theorem and remainder theorem from grade 12 to help you factor that. But if you have your calculator, that's a lot faster. Our last question in this section. Find the equation of the tangent and normal lines. Oh no, not quite last, second last question in this section. So first of all, we're going to take our equation and change the x to the 2 to x to the -2 so that everything is in a form that we can do our power rule. Then we can find our derivative. When you get x to the -3, you might want to rewrite it as a positive exponent because now we can evaluate. When x is 3, our slope is going to be 6. And that's the slope, or sorry, when x is 3, our slope is going to be -1. And our point, because in order to find an equation of a line, you're going to need a point and a slope. So how do you find the point? Well, you know x is 3. You can plug that 3 back into your original equation and find the y-coordinate on that graph. In this case, it's going to be 6. And then just use your point and your slope and find your 2 equations. Let f of x equal kx to the 4. The point 1, k lies on the curve of f. At the point P, the normal to the curve is parallel to -1/8 x. Find the value of k. So again, this is some working backwards. We have to look through our equation and see what we already know and see what we could find out. Okay? So, first of all, we know the slope of the normal is going to be -1/8 because it's parallel to the line y equals -1/8 x. If we know the slope of the normal, we know the slope of the tangent. The slope of the tangent is going to be related to the derivative at the point P. So we can find our derivative by bringing the exponent out in front and subtracting 1 from the exponent. And we know that when we plug in x equals 1, the slope is supposed to be 8. So plugging in x equals 1, the slope is supposed to be 8. Only that 1 is cubed. You can now solve for k. How many marks would this be on an IB exam? Between 4 and 6. Okay? They would give 1 mark for knowing the slope of the normal because you made an idea. They didn't tell you the slope. They said it was parallel. So you had to figure out that the slopes are the same. Then 1 mark for figuring out the tangent. So we got 2 marks already here. 1 mark for finding the derivative. 1 mark for knowing to plug in 1 and the derivative is 8. So that's already 4 marks. This last, it might have been a 5. This last little bit might be only 1 mark, those 2 lines. Might be 2 if they get extra generous. That's a lot of marks, right, for a question? So basically everything that you figure out is awarded a mark, which sometimes makes the marks out of a lot compared to things previously.